Welcome back to CIS101. This week we're going to talk about Chapter 12. And as you remember, before in the last class, we talked about databases, including, going over briefly what we call a mile wide and an inch deep, a little bit about database types, a little bit about database sorting, how they sort, and a little bit about the people who work with and administer and create databases. This week we're going to talk about in Chapter 12, behind the scenes, networking and security in the business world. And you should notice that a lot of what we're going to talk about today overlaps with what we've talked about in the past. We're simply building about what we talked about in previous chapters. Okay? And we're specifically going to get into a little bit about client-server network basics and servers and network topologies. And again, if this sounds familiar to you as we get into it, it's going to be because this is largely what we've talked about in the past. Okay, it's an overview of it. And of course, a little bit of review for why you want to learn this sort of things. If you look at in the Chicago area, in the Chicago metro area, the job postings are related to technologies like 5G, which is, of course, a faster, possibly more efficient type of wireless, artificial intelligence. These types of jobs postings and the support for the people who were researching this and developing products increased 73%. Okay, the top 3 tech occupations in the Chicago area in 2018 were software and web developer, computer system and cybersecurity analyst, and network architects, administrator, and support specialist. Companies in nearly every industry were expanding their tech teams, and we're still seeing this, especially seeing this with the compliance companies are finding themselves in with regard to COVID work restrictions. Okay, there's a huge focus on focusing on cybersecurity and new capabilities and remote learning. Okay, and remote working. And bear in mind that, yes, it's nice to talk about all the job opportunities and stuff. The median wage for all Chicago area tech occupations in 2019 was more than $82,000. That's pretty decent. And again, this gets us back to in 2019, before the infection of the spread of COVID and our compliance with the various quarantine and lockdown measures, the average household salary in the United States was $60,000 a year. That's household salary. So that the individual salaries averaging $82,000 for just one person, that's pretty decent. That's hard to, that's better than, as we like to say, a poke in the eye with a sharp stick. Okay, and another way to look at it is we're looking at a huge, and it's not going away anytime soon, gap between the cybersecurity professionals that are needed by the various companies and organizations in the U.S. and really around the world, okay, and the fact there are simply not enough, people who have the training and the background and, and the desire to do the stuff. And bear in mind, as we talked about in Chapter 8 on security, this stuff is not hard to do. It's not really that hard to learn, but there's a perception that it is. So people just say, oh, I could never learn to do that. When in fact, we're back to, okay, we need to lock the doors. We need to use our head. We need to not just insert any flash drive into any computer system. We need to use our heads just a little bit. And again, specifically, network security salaries in the Chicago area, average base pay is $81,000 a year. That is the average of all the people with no experience, which is down to $61,000, which is still pretty decent, with no experience, to the people with experience. And these are not managers. These are security salaries. On the high end, they're $111,000, more than 6 figures. This is pretty decent. Okay? Another way to look at it specifically, because realistically, the people in this class are not worried about, realistically start going someplace and making $116,000 a year, or really $117,000. You're not going to start out doing that. But beginner network engineer salaries in the Chicago area are $67,000 a year. That's not bad. That's somebody with a 2-year degree and no experience. This is pretty decent. And as as you gain experience, you're going to be able to move up to, if you want to, positions. And there's a video on how to on people doing this sort of thing on network security salaries. Okay, and at the high end, cybersecurity engineers. These are people with experience and at least a 4-year degree. Generally speaking, if you're talented and play your cards right, yes, you can have a 2-year degree and be a cybersecurity engineer. But realistically, and the companies you work for, and as you go, as you position yourself for these roles, you're going to want to go ahead and pick up the additional education simply to have it, as a credential on your resume. And again, the things we're going to talk about today include listing the advantages for businesses of installing a network, explaining the differences between a client-server network and a peer-to-peer network, talking about the common types of client-server networks as well as other networks businesses use, listing the common types of servers found in client-server networks, and describing the common types of network topologies and advantages and disadvantages of each one. And if this sounds familiar to you from previous chapters, yeah, again, this is largely going to be overlap on what we have talked about in the past. And again, as we have mentioned previously, a network is a connected system of objects or people. Okay, this should sound real familiar to you by now. And a computer network is a collection of computers and other hardware devices connected together so that users can share the hardware, the software, and the data, as well as, this is the biggie, because very few people have a computer, have a phone, have a Chromebook or a Kindle without the ability to communicate with each other. And of course, the largest computer network in the world is the internet, which we tend not to think about. We just log on. I want to look up this. I want to research that topic. I want to find out how much this costs, especially with Thanksgiving and Black Friday. And this week, Cyber Monday, a lot of companies are, well, last chance for Black Friday deals. And those Black Friday deals are extended through, this week, depending on the company and how much they have to sell and how well they're selling it. And again, when we talk about the client-server network basics, we're talking about a network being a group of 2 or more computing devices. Can be you and your friends talking on your smartphone. That is a computer network of a various type. And it becomes even more pronounced if you are implementing VPN connections for your phones. Most people don't. A phone conversation generally is not something that anybody else is going to have a tremendous interest in, but you could if you wanted to. And of course, these networks are configured to, anytime you're talking about a network, talking about 2 devices that are configured to share information and resources such as printers, files, and databases, voice communication, sending pictures to your friends about stuff. And of course, businesses spend the money on the hardware, on the software, on the salaries for this stuff. And we're talking about hundreds of thousands and millions of dollars, okay? Because it gains them a clear business advantage. And we've talked a bit in the past about the digital divide between individuals, those who are computer literate, those who are not, but also between countries and economies. And it's not fair, but it's, the more digital literate an economy or a culture is, says the faster they are pulling away from the cultures and the economies that are not digitally literate. It's not fair, but it's the way it is. And if you think about it, the UN's definition of computer network penetration, in the world, not in the U.S., in the world, okay, is when a village has access to 3 phones, okay? And if you think about it, in the U.S., we would look at that as like, you're kidding. Just about everybody has a phone. In the world, not just about everybody does not have a phone. Okay. And of course, when those computers are communicating with each other, they're utilizing protocols and services. And again, this is why people working in this field get, start out at in the 60s. Okay, because the protocols and servers are what facilitate the communication between 2 network devices, just like speaking languages. It's very easy for you to communicate with somebody relatively when you speak the same language. But if you do not speak the same language, and in Chicago, this is an easy point to make, it is much more difficult to communicate with 2 people. Go down to Ukrainian village, and if you don't speak Russian or Ukrainian preferably, and the other person doesn't speak English, it can be really, really hard to communicate effectively with them. In the stores, you're reduced to pointing to what you want, nodding your head yes for the things, and then they hold their fingers up for how many you want. You have to, when they hit the right number, you say yes. Protocols and services are how we perform data encapsulation. They provide that common language for communicating devices, and they provide either a connectionless, like in wireless, or a connectionless, or a connection-oriented services. And when we talk about connectionless and connection-oriented, we are not talking about wireless versus wired connections. It's an easy jump to make, but it would not be a correct one. This is a theoretical type of connection process protocol. And of course, as we've talked about in the past, the OSI model, the Open Systems Interconnect model with the 7 layers, okay, all theoretical, but it's a standard. A company or an individual does not have to manufacture hardware or software that complies with this, but this is a standard. It's like tires. You don't have to manufacture your tires to an existing standard, but if you do not, it's much more difficult to work with anybody. If you do, it becomes much easier. Okay, when we briefly mentioned connectionless and connection-oriented protocols, and when we talk about connectionless, we're talking about those protocols in the OSI model layer, okay, that do not require a connection. They have very little overhead. They're fast, but they're unreliable. And a classic example of this we like to use is snail mail. Okay, you can mail a letter, you can mail a postcard. And you're pretty sure it's going to get there, but you don't know exactly when it's going to get there, and it may not, in fact, get there at all. Something else closer to home for most of us. When you send an email message, when you send a text message, those also use connectionless protocols. And I mean, we pretty much expect that email to get there, and it generally does pretty fast. Doesn't always. And we generally expect our text messages to get there. But the reality of it is they don't have to. Every now and then, someone will basically say, well, what about my text message? Didn't you get it? And the person says, oh, I don't remember seeing it. And they may not have seen it. They may not have gotten it. It is not guaranteed that they will. Generally speaking, part of connectionless includes notification if it didn't go through, that they'll notify you, hey, we couldn't deliver that message. But again, it is not guaranteed. And we contrast this with the connection-oriented protocols, like a phone conversation, that require that active connection, establishing and maintaining that connection requires more overhead. They're a little slower, but they're a little more reliable, okay, because you generally know, unless the other person just is talking way too much and won't shut up, that if you lose your connection, you pretty much know it right away if there's any listening going on whatsoever. And again, this gets us back to the OSI model and those protocol layers, and there are those 7. And strictly speaking, the application layer in any device, including our phones, will always talk to the presentation, which will always pass information back to the application, and the presentation layer only talks to the session layer, and session layer only passes information back up to the presentation layer. Okay, they always travel hierarchically in sending the data. But from a practical standpoint, the application layer in your phone only sees and only knows that it's seeing and communicating with the application layer in your friend's phone. It doesn't, stop and think about all the 6 other layers that everything is traveling through. It's being handled for it automatically if it's doing its job right. All you know when you're working on your Chromebook, your MacBook, or your laptop, or whatever computer you have, is your application layer is working with the application layer of the other devices. When you're browsing the web, you're looking up research, and you're looking at things that you want, you're looking up anything for whatever reason, you're dealing with the application layer on the servers, generally speaking, at the other end. Okay. Now, and of course, the advantages for this, again, the reasons why businesses are willing to spend, and individuals are willing to spend hundreds of thousands, millions of dollars, salaries, hardware, and software, is because it enables resource sharing, and I still remember 20 years ago, when I was doing audits, you could still run into companies that would have a printer on every desk, just in case. And 30 years ago, every desk had its own printer. Okay, Facilitates knowledge sharing, which is a huge individual and business advantage. Enables software sharing, okay, which can be delivered to client computers from the server, um, like Office 365, and enhances communication, especially, and we tend to forget that email is not just a really neat, convenient tool for individual communication. It is the #1 business communication tool or business productivity tool in the world because of the ability to send information, include files, include links, and it has actually been part of the creative destruction. There used to be a whole subclass of package delivery in various in every city, and basically were bike riders. Bike riders would basically do extra money doing package delivery from companies to companies within the metro area, and that has pretty much been destroyed because people can fairly easily, in most cases, simply take attach the files they want to an email and shoot it over to the person, generally even faster and more conveniently. Okay, when we talk about the topologies, okay, for connecting these networks together, we're talking about basically two major types. The client-server network, which is centralized, more efficient, requires a little more overhead, a little more thought, a little more money to go into. And then the peer-to-peer, which are generally, the general rule is this is for less than 10 computers. It's decentralized. They're fairly easy to set up and run. But once you get beyond 10 computers, the background noise makes them a little inefficient and a little more troublesome and unreliable. The advantages of client-server networks, despite the fact that more money, more time, and more trouble and more salary go into it, is you have more efficient data flow and you have much greater scalability. You can, if you belong to Twitter, if you belong to Facebook, you belong to Profile or Proffer. These are all services that have hundreds of thousands of possible members. Okay, and this is in your textbook, breaks it down to various types of client-server networks, from the personal area network, like you and your phone on your Bluetooth, the local area networks, like this, like a room in a building, or the network on Triton campus. The home area networks, which is simply another type of local area network, but most of our homes with our fiber and our cable, well, not necessarily fiber, but with our cable, with our TV, smart TVs, and our phones and our computers are all part of a home area network. Our wide area networks, again, the classic example of this is the internet, or any large company with branches across the world, across the nation. And our metropolitan area networks, and I apologize for this popping up. Very irritating when it does this. Okay, and of course, all of these network types, as you remember from our previous classes, okay, have to have certain components in common. Every device on the network has some sort of a network interface cord or network adapter card that's installed that basically has a job of putting information out on the networks and collecting information up from the network for the particular device. You're all going to have nodes or devices of various types, and if it's working on any kind of a network except a peer-to-peer network, it's going to be using a switch of some type, or a gate or a router of some type, to basically, like traffic lights, route the information around from where it is to where it needs to go. That's what they do. And of course, this gets us into the servers and network topologies, okay? And on the more complex side, getting away from peer-to-peer, we have our various server specialties. We have our print servers, and bear in mind that a print server and a web server are virtually the same thing. The only difference is that a print server is taking information and laying it out to be sent to a print device to be printed, and a web server or a cloud server is taking that information, laying it out to be displayed on a web page. They are essentially, for that, except for that, they are essentially the same thing. We have our application servers, like when you log on to and you want to utilize Office 365. You have your database servers that provide the information when you and I go out on the internet and use Google or DuckDuckGo or any other server, and I like Google Scholar myself, to look for information on a particular topic. And the database servers are the ones that serve up that information for us. When you do a search on Google, and the results you get are basically the response from the query you've launched, to the Google servers. Authentication servers, and it can be a dedicated server, or it can be a dedicated service on another type of server. And these are the services or servers that keep track of the users that are logged on to the network and let you on or let you off. If you've ever had, and this happens to be on a daily basis, where you have to type in your password to get to somewhere. You've been going through this. Your file servers, these are the devices that store and manage files for network users, like we have here at school or in any business. Anytime you go on any store, or Amazon.com or eBay, and you log on to it, and they have a record of all the things you've done, you're looking at a file server. Email servers, which are the devices that process and deliver incoming and outgoing email, and very closely related to them are text messages, and things of that type. Communication servers, which handle all the communications, like your voice and text communications, and they're closely linked to the email servers. And then again, the web cloud servers, which are very, very similar to print servers, except instead of doing print files, they're basically laying out their files and information on the internet. Okay, and when we're talking about the various topologies or architectures, if you will, just like you drive through a neighborhood and say, okay, that's a 2-flat, that's a ranch style. You look at the various houses, buildings, say, okay, that's the sort of building that is. Same thing with network topologies. One of the very first network topologies, and one of the easiest, and still in use, and one of the easiest to set up, especially for short-term use, is what we call a bus topology, where you basically have a cable, like a bus route, and all the devices connect to the cable, and all the information travels on the cable and sent to every device, and the NICs, the network adapters, network interface connectors, and network adapters on each device basically are listening, and when they hear traffic that is pertinent to, that is addressed to their machine, they will basically allow it through, and it goes into the machine, and the machine acts on it. Okay? This is very easy and quick to set up. It has a little bit of a problem in that, just like in a traffic jam, if anything happens to that cable in any way, shape, or form, all the devices on the bus topology are down and cannot work except individually. And not that most businesses use a bus topology. Some of them do, but this is a good example of why so many businesses are slow to move to Office 365. They prefer Office 2016, Office 2019, where the Office software is still on the local machine, so that any time that there is a network interruption of any type, they don't have to stop. They can continue working locally and basically get their information and their ducks in a row to the extent possible for when the network comes back up again, and they can resume communication. We also have our ring topology. Now this is like a traffic ring, if you've ever seen one. These are a certain amount of infrastructure goes into this. This is usually used by large corporations that can justify the time and effort, but ring topologies are very efficient. Just like a traffic ring is about 400% more effective than your traditional stop-and-go intersection. Okay, a ring topology, okay, is very fast and very reliable, okay, provided that you are willing to put the time and trouble into getting it up and getting it maintained. And basically, in a ring topology, if this device wants to send something to this print device, for printing, okay, it's not going to send it that way. All the information in a ring topology is going to go in one direction, okay? So it would actually go all the way around to here, but because all the traffic is going in one direction, the chance of collisions or problems with delivery are much reduced. It's fairly fast and very reliable compared to other types, but it does take some time and money to get them up and running. Large companies like them a lot. The 600-pound gorilla in network topologies is what we call the star topology, because they scale so well. They scale well from computer networks of just a few computers, slightly more than 10, to potentially thousands of computers and computer sub-networks. And basically this is where you have, like in a typical classroom, or in Triton College is made up of multiple subordinate networks that are all star topology. you have a group of computers of various types that are all connected by a switch, and it can be wired or it can be wireless. And basically, the switch is responsible, and it's usually redundant. There's a backup. It's responsible for basically sending and receiving communicate like a traffic light. It tells the traffic where it's going to go. When you look at the various types of topologies, bus, ring, and star, and there are hybrids, okay, which we take, okay, you want this and you want that. And a good example of a hybrid technology or topology would be most businesses, including Triton College, where you have most of the networks are star topology, but then you have your wireless connections, which essentially make it a hybrid, okay, because they are not necessarily going to be star. But you have your bus, which has its advantages and disadvantages. You have your ring, which has its advantages and disadvantages. And you have your star, which has its advantages and disadvantages. Okay? And they all, and one of the advantages and disadvantages of all of these is the time and effort and the money involved to get them up and get them running and then to keep them running. When you're looking at setting up a business network, you're looking at the types of transmission media you're going to be using, the network adapters, and again, network adapter and network interface connector are the same thing, and the navigation devices you're going to be using, and the network operating systems and network security that you're going to be using. And you have to have some sort of network operating system. And you don't have to have, just like you don't have to have a lock on your door of your home or a lock on the door of your transportation. The lock on your locker if you're back in high school. But the reality of it is, yeah, you're going to. I mean, it's pretty much, unfortunately, it's pretty much a given that we have to have network security. And it's not necessarily malicious. People sometimes accidentally do things that we have to basically prevent the rest of us from being affected by. And when we're talking about that, we're talking about describing the types of wired and wireless transmission media used in networks, talking about describing how network adapters help move data around a network, talking about what are MAC addresses, media access control addresses, how they are used to move data around a network, some of the various types of network navigation devices and how they help route data through a network, and why network operating systems are necessary for networks to function. And a network operating system, as we will talk more about in some detail, is like the computer operating system, but instead of operating your computer or operating your phone, it operates the network. And ideally, in the background, you and I don't even notice that it's there. It just does its job, and we're just, we're on our phone conversation, and we're not worrying about what's making the phone conversation work. We're just happy that we have the conversation. And we'll talk about some of the major security threats to networks. And again, a lot of this sounds like, yeah, haven't we talked about this before? We have. A lot of this is building on what we have talked about in the past. And again, this is not a hard topic to really learn well and go out and make a fairly decent salary at. A big part of it is just not letting yourself, like programming. A lot of people who could program just, I could never learn to do that. That's just too hard. And really, it is not that hard to learn, and they absolutely could learn to do it if they were really to just put in the time and effort and convince themselves that it is possible. When we're talking about transmission media, what type we need, some of the things that any organization wants to consider, and ultimately it comes down to, a person or a shop. It says, what is a maximum run length, of the transmission going to be? And generally speaking, we're looking at in lengths of 100 segments of 100 meters. It can be less. What is the bandwidth that's required? And again, this is like, can you get by with one lane going both ways, two lane with some flexibility in the middle, dotted lines in the middle, more than two lanes like we have on Eisenhower or on the interstates? How many lanes do we need? How can we afford? How many can we get by with? What are we going to ultimately go with? The bend radius, if we're using physical cable, how sharp, can the corners be? How much is it going to cost? Because, we'd all like to have, the most expensive car out there. But can we afford the most expensive car out there? What's it going to cost to install this? Because that goes in not just how much the cable is going to cost, but how much is it going to cost to install. In a perfect world, everybody would be using fiber optic. But the reality of it is fiber optic is very expensive, and then very expensive to install and get it up and keep it running. So, what we'd like to have it, but, is some non-fiber optic, type of cable or transmission media going to be, really good enough for our purposes? And what kind of interference are we looking at? Both physical and non-physical. Can be, in Chicago, you very often will have just about every case on the tops of all the towers, and within the higher floors of all the towers, you're going to have a network antenna so that they can communicate with other segments of their network that are not in that tower. They're in another tower, and those work really well, except when it's raining, when it's snowing, when it's foggy. If they are laser connected, then they can run into problems. The 600-pound gorilla in transmission media is what we call the twisted pair. And it's called twisted pair because if you open it up, you will find pairs of cable twisted around each other, surrounded by a protective sheet. Engineers are very simple and very matter of fact. Works very well. There are various grades of it. It is fairly cost efficient. It is fairly effective. It can be unshielded, which is the common type. It can be shielded, and you will find it used for a variety of purposes. It generally has a run length of 100 meters. You also will find in business networks as well as in individual networks at the home what we call coaxial cable. If you think about the coaxial cable connections for many of our TVs and stuff like that, that design actually goes back a long way. It goes back before the 19th century. Used in the connection type with that little with a little prong that you would insert into the connection, and then you twist for it to be held. This VNC stands for British Naval Connection because it's actually a connection type that was developed before 1900. The old steamships and coal ships used to constantly, and movement on the water, they used to constantly vibrate, so they would actually have that design so that once they were inserted and twisted to stay on, they would stay on regardless of the amount of vibration that was occurring. And of course, twisted pair cables include fiberglass, which is very fast, very efficient. And once you get it up and get it running, it's really hard to beat in terms of speed. You're talking about speeds that approach the speed of light. This is really fast. Your standard copper thread and twisted pair can handle like 27 simultaneous connections per second. Fiberglass is fast enough that it handles like 27,000 connections per second. It's really fast, but really expensive. And of course, with all of these, you have your network interface connectors, you have your network adapters. They provide those three critical functions. They generate signals for network transmissions. They send and receive data, okay? And then the receive part means that they act as gatekeepers for information flowing to and from the client computer. Network interface card, network adapter looks at all the information that's flowing out that's on the internet, and it only will let in that information, like a concierge at a hotel, that is addressed to their particular computer device. That's all they care about. Okay. And again, as I just said, basically your network adapter is responsible for screening all the information and only allowing in the information that is supposed to be there. Okay? In terms of traffic lights, in terms of managing that information on the internet, we have switches, which rebroadcast data to appropriate network nodes. We have bridges, which are a dedicated type of switch, simply like a bridge. Okay? They send data between two different collision domains, like the bridge between Whiting, Indiana, and Chicago, the Chicago Skyway. And then we have routers, which send information between two networks, okay? Like a fairly complex traffic light with all sorts of left turn, right turn, go straight ahead, turn signals, okay? We also have our network operating systems, and these are one step up from our computer operating systems in that they have to be installed on each client and server computer, and they provide a common protocol basis, common language, if you will, for the computer network to operate. They facilitate the communication. Some types of network operating system, like peer-to-peer, is built into the Windows operating system, and these not by no means the only, but practically speaking, the standard, okay, for network operating protocols is TCP/IP. It's not the only one out there, but it is the standard that everybody uses because everybody pretty much plans to be getting on the internet at some point. And again, TCP/IP is a standard for the internet. So as long as you're using a standard to communicate on the internet, you might as well, it's easier to simply incorporate it on your local computer. You do not have to. You can have a subordinate network that is not on the internet, that is using some other protocol, and this actually has the advantage that it's much harder for people to hack into a network that is not using TCP/IP, because you, by definition, can't get to it across the internet. If you can get to it, but then when you get to it, you're not using TCP/IP. You are, so you're kind of stuck. Okay. The downside to that is that without having specifically configured gateways, says the people on the network can't get to the internet. So you have to trade. Is this need for security that great? Or not necessarily everybody always understands this. Or could you actually, is it, or do you need to get on the internet, or do you not need to get on the internet? When we talk about security threats, we're talking about the types of security threats. They can include human errors and mistakes, like when you bring your child to work day. They can include malicious human activity, which is what we tend to think about when we think about security. And they can include natural events and disasters, like more than 10 years ago, they were doing some drilling and some digging in downtown Chicago, and they actually, in some of the basements of some of the towers, and they actually, by mistake, dug into some tunnels that they didn't know, the old canal system tunnels under the buildings that had been roofed over and everybody had forgotten about, weren't even on the maps anymore, and they breached them, okay, in their digging efforts, and suddenly some of the buildings in downtown Chicago started flooding and didn't know where it was going to go, okay? Or it could be an asteroid. My spouse used to joke that the reason we had a boat was a good thing, because if an asteroid ever hit Lake Michigan, we could all hop in the boat and we'd be safe. Volcanoes, asteroids, earthquakes, things happen. Security also goes into authentication to allow people in who are supposed to be in versus people who are not supposed to be in. And the access privileges are utilized to restrict access to various levels. Not everybody should, be allowed to install and run anything that they want to. I'm sure everybody thinks they should, but the reality of it is that you really want to say, okay, you can do various things, you can do various things, and you can do various things, and those things are not always going to be the same. They really should be based on the needs of the organization. Physical protection measures include things like access card readers, retinal scanning. These are ways, basically locking the door to keep people out you don't want to get out, or locking the device to keep people out you don't want to get out. Fingerprint scanning, facial recognition. It can also be username and password, which is something most of us are more familiar with. And they can also be at a higher level firewalls, which are utilized along with, and they're distinct from, antivirus software. They're like a concierge in that they block people from getting on the internet or getting into a network, doing things that we don't want them to doing. Or maybe it's not a matter of them doing things we don't want them to be doing. They simply don't belong there for any way, shape, for any particular reason. And for that reason, we don't want them on there. Okay, for extra credit, you have a couple of options, just like you normally do. Either describe the common types of network topologies and the advantages and disadvantages of each one, or list some of the major security threats in networks and explain how network administrators can mitigate these threats. Again, we're looking for about 100 words with a reference link, and submit this in assignment 14. Okay, we have talked a little bit about the advantages for businesses of installing a network, some of the differences between client-server network and peer-to-peer network, some of the common types of client-server networks, some of the common types of servers, and some of the common types of network topologies. And again, this has been a broad brush, and you can certainly learn more about this, and I urge you to look at learning more about this in CIS101, which is an introduction to networking. We talked a little bit about some of the types of wired and wireless transmission media. We've talked about how network adapters help data move around a network. We've talked about media access, MAC addresses, media access control addresses, physical addresses and how they are used to move data around the network. We talked about some of the various network navigation devices, a little bit about network operating systems, why we have to have them, and a little bit about some of the major security networks. And again, if this sounds really familiar to you or somewhat familiar to you, it's because all these topics are topics that we've talked about previously. And these are all topics that are gone into, we spent an entire semester in CIS101 just talking about these sorts of things. Alrighty, things to think about. You want to read through Chapter 12, Network Security for Businesses. You want to get in your labs on PowerPoints 1 through 4 and in PowerPoint 3 approximately, depending on your edition. When it talks about inserting audio or video, just skip that because it just makes the files way, way, way too big. And then the PowerPoint quiz was due last week. You need to get that in. And then in a perfect world, we're moving into Access, Chapter 1 in the lab book this week. Okay? And bear in mind that the final exam is going to be in 3 weeks, the week of December 11th, December 14th. You need to be thinking about that. Okay. Subject to your questions. Okay, let's move on to the lab part of the class and get some things done.